This video is going to cover when to use inverse operations. Sometimes it's difficult to know when we need to use inverse operations to find a solution or solve for a specific variable. There are times when we need to use inverse operations and times when we do not need to use them. The inverse of multiplication is always going to be division. Make sure you fill in that blank. The inverse of division is multiplication. Inverse of addition is subtraction. The inverse of subtraction and addition. But when we do need to use inverse operations, we want to make sure to use the appropriate inverse operation given the operation that is shown in the problem. These are things you already know. You've been learning since elementary school the inverses of multiplication and division and the inverses of addition and subtraction. Let's look at a couple of examples. The first example that's done for us asks us to solve for x, and the equation is x equals 12 times 4. In this problem, since x is by itself and the operation is on the opposite side, we do not need to use inverse operations. So we can see that it says x equals 12 times 4. X is already isolated or by itself. All we need to do to figure out the value of x is find 12 times 4. So we're going to multiply 12 by 4 to get 48. Our solution is x equals 48. In example 2, we're solving for x. We have 12x equals 60. In this problem, since x is not by itself and x is being multiplied by 12, we need to use inverse operations. So what I see is that x is being multiplied by 12, and I know that the inverse of multiplication is division. So what I will do is I will divide both sides of that equation by 12 to solve for x. When I take 12 divided by 12 on this left-hand side, and this is something we'll get used to, is showing those inverse operations on both sides, 12 divided by 2 is going to get me 1x, which is just x. When I take 60 divided by 12, I get 5. So I know that x equals 5. I also know that x equals 5 makes this equation true, since if I take 12 times 5, I get 60. Now, I know some of these equations right now are really simple, but they're going to get more difficult. So it's good for us to set this foundation now, so when we get to the more difficult equations, we'll be able to solve those too. Let's look at example 3. We're going to solve for x. Our equation is x equals 16 plus 12. Like example 1, x is already by itself. So all we need to do to find our solution here is 16 plus 12, which is 28. So the answer is x equals 28. Let's look at example 4. Solve for x. 12 plus x equals 16. Like example 2, x is not by itself, and I need to isolate x. And I know that I have 12 being added to x. The inverse of addition is subtraction, so I will subtract 12 from both sides to find my solution. So we can see here at the bottom of our screen, we're going to subtract 12 from both sides. We get x equals 4. The reason why we do this on both sides is 12 minus 12 is 0, and 0 plus x leaves us with x. So our solution is x equals 4. Again, we also know that 12 plus 4 gets us 16, so that helps us see that our solution is x equals 4. I know this might seem simple, but sometimes we have students who look at something like example 3 and try to subtract 12 from both sides because they think that they're trying to move something over to the opposite side of the equation rather than just find the value of x. And again, I know that these one-step equations are very simple, but they're going to get more difficult. So that's why it's important to practice this. Now, as we work in some of these examples that I ask you to try, if you want to work ahead, that's fine. Just make sure you're checking your solutions and following along with the video to make sure you truly understand how to find the value of x. So our directions say for these problems to determine whether inverse operations are needed to find the value of x, then find x. Let's look at example 1. Do you think we need to use inverse operations? In this problem, we do not need to use inverse operations. And the reason for that is that x is already by itself. So all we have to do is do 72 divided by 9, and I know that 72 divided by 9 is 8. My solution is x equals 8. You'll notice that I circle my solutions. I think that's really important to do for you to check your solutions, and when I, as the teacher, am checking your solutions as well. Let's look at number 2. We've got x divided by 6 equals 5. X is not already by itself. So in this case, we need to use inverse operations. When we go to use inverse operations, look at what's happening to the variable x. We're dividing by 6, and I know the inverse of division is multiplication. I will multiply both sides by 6. Now, I know this seems weird, like divide by 6 times 6. Does that really cancel out? It will. If you take any number and divide it by 6 and multiply by 6, you'll get back to that original number. What I really want to do, though, is on this right-hand side. I want to find 5 times 6, which is 30, and that's going to give us the value of x. Let's take a look at number 3. We have x plus 9 equals 14. Do we need to use inverse operations? Yes, we do. X is not already isolated or by itself, so we have to use inverse operation. I see that we're adding 9 to x, and I know the inverse of addition is subtraction. So I'm going to subtract 9 from both sides. We can see that 9 minus 9 will cancel out. We need to do 14 minus 9, and that's going to get us 5 for our solution. I want to pause here for a moment. I know some prior teachers will have students draw a line through their equal sign, and you are certainly welcome to do that as you work through the problem. I know there's a lot of teachers who teach it that way. I sometimes do it. It is a way that I do show my students how to do the problem so we can see those inverse operations on both sides of that line. It's up to you if you want to show it. It's not required. The other thing I want to remind you of is if I'm moving too fast through these things, make sure you pause the video as needed so that you can copy down the examples. Let's take a look at number 4. We have 8x equals 24. Are inverse operations needed? In this problem, inverse operations are needed because x is not by itself. Now, what is happening to the variable x? I know there's nothing between the 8 and the x, but this is 8 times x. We often will not show multiplication between a number and a variable. We call that number the coefficient. We'll talk about that term later on this year. The inverse of multiplying by 8 is to divide by 8. So to find my solution, I'm going to divide both sides by 8. I want to calculate this 24 divided by 8 to get my solution. When I take 24 divided by 8, we'll go ahead and highlight that for you so you can see what calculation we're doing. We're going to end up getting x equals 3 for our solution. All right, moving ahead to number 5. Let me move this up a little bit. Do we need inverse operations for the equation 18 minus 5 equals x? We do not need inverse operations here. And the reason why we do not need inverse operations is that x is already by itself. Now it's by itself on the right-hand side, but it's already isolated. So all we have to calculate is 18 minus 5 to get 13 for our solution. So 13 equals x, or we could write x equals 13 as well. Taking a look at number 6, we have 9 times 3 equals x. Do we need to use inverse operations here? Like number 5, variable x is already by itself, and we do not need to use inverse operations. All we need to do is calculate 9 times 3, which is 27. We get 27 equals x, or you can write it as x equals 27 as well. Number 7. For this equation, x is not by itself. It says 17 equals x minus 5. What I see happening to the variable x is we're subtracting 5. The inverse of subtracting by 5 is to add 5 to both sides. On this right-hand side, minus 5 plus 5 will cancel out. We'll be left with x. We want to do this calculation. Again, I'll highlight it for you if that's easiest. We need to calculate 17 plus 5 to get 22. So we will get 22 equals x. Oh, and I forgot to reveal the box that says we need to use inverse operation, but we do need to use those because the variable x was not by itself. Again, 17 plus 5 is 22, so we know that x is equal to 22. In our final example, number 8, 12 plus 4 equals x. Like questions 5 and 6, we can see that the variable x is already by itself. Inverse operations are not needed here. All we need to do is do 12 plus 4 to get 16. We end up with a solution of 16 equals x, where x equals 16. Again, the purpose behind this lesson is to start to set the foundation for inverse operations, to talk about when we need to use inverse operations and when we don't need to use them. We'll be talking a lot more about equations as we go through the year. So be ready for that as we approach the next few months. And thank you for listening.